Hello guys, welcome to the portal, the mathematical science portal. It's your teacher here, Karabo Tshehla. Okay, this is part 2 of naming of haloalkanes. Okay, so here we are going to name a few examples. I've brought different examples, mix masala. So now let's start with this one, example 1. Okay, let's start by naming. Remember the guidelines from the previous video that we did, the one of naming haloalkanes. So if you haven't seen it, please go back and see those guidelines before attempting this one. Okay, so now let's start naming our haloalkane. Okay, so now as one of the guidelines says that alkyl group can be preferred over the halogen depending on a situation. This is the situation, right? And also in some other situation, the halogen will be preferred over the alkyl group. So in this situation, the alkyl group is preferred over the halogen. Okay, why? Because of the alkyl group is closest to the nearest end carbon, to this carbon here, carbon number 1, as compared to that bromine. So now first things first, we can see that this is a haloalkane, right? So this is an alkane. It has a substituent of a halogen. Okay, so now let me take my favorite color, which is red. If I say this is 1, 2, 3, 4, 5, 6. Okay, so this becomes my branch. Okay, so now if I count from right to left, right, I have my methyl on number 2 and my bromine on number 4. Okay, so now the name will be, as you can see, the longest chain is what? It's a hex. Okay, so now I have a 4 bromo. I have 4 bromo dash 2 methyl hexane. 4 bromo 2 methyl hexane. All right, so let's count the total number of positions, right? Total number of positions is going to be 2 plus 4. 2 plus 4, which is 6. Okay, so now let's say let's say I count from here, from this part. Let's say I say 1, 2, 3, 4, 5, 6. Okay, so now in that way I would have the name of 3 bromo dash 5 methyl hexane. So now if I were to do my total, number of position, I would have 3 plus 5, which is 8. So, and as you know, 6 is less than 8. So, and the one that we want is the one with the least total number of positions. So, it means that this is the correct name and this one is not correct. So, it proves that guideline saying that we must start numbering to the carbon that is nearest to the end. You see, that is nearest to the end. So this one is a bit further from the end. This bromine is a bit further from the end, but this methyl is closer to the end. You see, so hence this is our name is 4-bromo-2-methylhexane. So now this is wrong, hence I put wrong on it. So I will not repeat the same thing on all the problems because you might not have time during examination. You won't be able to repeat this as well. You can just do it by just looking at the problem. So you don't have to write this, so you can just do it on your calculator if you are not sure. Okay, so now let's go to number 2, example number 2. Example number 2, well, it's almost the same as this one, but not the same. Okay, so how many carbons do we have? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we start numbering from the nearest end. Okay, so where is the nearest end? Chlorine is next to the nearest end, and also the methyl next to the nearest end. But then now, which one are we going to take? So if I say if I start from left to right, I'll have 1, 2, 3, 4, 5. Okay, but if I say I start from right to left, if I start from right to left, this will be 1, and then this will be 2, this will be 3, this will be 4, this will be 5, right? So now the total from right to left would be the position of the methyl at carbon number 2 plus the position of the bromine at carbon number 3 plus the position of the chlorine at carbon number 4. It will be how much? 7 plus 2, which is 9. Okay, so now what about the red one if I count from left to right? So the total would be the position of the chlorine at carbon number 2 plus position of the bromine at carbon number 3 plus position of the methyl at carbon number 4. So here I have what? I have I have 9. It's still 9. Okay, so now here we have a scenario whereby numbering from each end gives us the same number, same total number. So now what do we do? So we go to that guideline that says if you are counting from either side and the total number of position is the same from either side, then we resort to alphabetical order. Okay, so when I say alphabetical order, it means that chlorine will be preferred over the methyl. So instead of starting from this side of the methyl, I will start from that side of the chlorine. So from 1, 2, 3, 4, 5. Okay, so Now the purple one is no longer needed. It's no longer needed, this one. Okay, guys. So now I can start naming. So my chlorine is number 2, my bromine is number 3. Even though my chlorine is number 2, when I write my name, I won't start with chloro because bromine comes before chlorine, right? So I'll start by saying 3 bromo, right? Dash 2 chloro dash 4 methyl heptane, not heptane, pentane, sorry, pentane. Okay, because we have 1 2 3 4 5. So we have a bromo at number 3, we have a chloro at number 2, and a methyl at number 4. So that is our name. Excellent. This is our name. Okay, so now let's navigate to the next example. Okay. All right. You can try this one before we do it and see what you get. Okay, so now this one we're gonna do it a bit quicker. Okay, so as you can see here, we have a methyl group in the middle here. This is a 5 carbon chain, so we have a methyl in the middle. So now we have Br and Cl competing. So between Br and Cl, which comes first in our alphabets is the B, right? So the B comes first before C. So now it means that I will start numbering from this side. 1 2 3 4 5. Okay, so now my name, excuse me, my name is 2. My name is gonna be 2 bromo, right? 4 chloro, 3 methyl, pentane. Okay, because we have 5 carbons there. So 2 bromo, 4 chloro, 3 methyl. Okay, so now that is our name there. Okay, so let's go to the next one. Okay, here let's check. We have 2 methyl groups here. Before I can do anything, let's count our longest chain. 1 2 3 4 5 6. Okay, so we have 1 halogen situated here is the Br, and then we have 2 methyl groups here. So if I say 1 2 3 4 5 6, okay, then 1 2 3 4 5 6, so it means I have an ethyl group there. So now which direction am I gonna take? If I count from this side, I have 1 2 3 4 5. Okay, and if I count from this one, I have 1 2 3 4, 1 2 3 4 5 6. Okay, so let's start with the red. Let's count from right to left. Okay, so you'll notice that even though I have a methyl here and a bromine here, they are on the same position. But notice this, that we have two methyls here, right? We have two methyls. So it's different than when we have one methyl. So, but let's continue. 1, 2, 3, 4, 5, 6. Okay. So now, if I would count my total of positions here, I have two methyl groups at position number 2. So I have 2 plus 2, okay, because there are two methyl there at carbon number 2. So I have what? I have a methyl, an ethyl group at carbon number 4 plus 4. I also have a bromine at carbon number 5 plus 5 is equals to. So here now I have 9 plus 4. So it means that now I have 13. Okay. So if I take the purple one and I count from this direction, 1, 2, 3, 4, 5, 6. So if I go from right to left and then I will do my total, let's see what do we get. So my bromine is at number 2 plus my ethyl at number 3 plus my 2 methyls at number 5. One methyl, the other methyl. Okay, so now let's check here. I have 10 plus 5, 15. So it means now the methyl groups, these two methyls are preferred over this bromine, this one bromine. Okay, so it means now we're gonna take the red one as our correct name. So I'm going to have 5 bromo, right? 5 bromo dash 4 ethyl. Okay, 4 ethyl because ethyl E comes before M. And then, sorry about that. And then we have 2.2 dimethyl hexane. All right, so that is our 5 bromine on carbon number 5, our ethyl on carbon number 4, and our 2 methyls on carbon number 2. So that is our name, the name of our molecule. That is correct. Let's go to number 5. You can do number 5 as an exercise. So you can pause this and do this as an exercise. So now I'm gonna give you the answer. So now here, as I'm looking, I have what? 1, 2, 3, 4, 5. Okay, and then here I have 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it means I have 2 methyl groups here. So now, am I gonna start from left to right or right to left? Okay, almost the same, almost scenario as the previous one. So here I have two methyls, and then here it's only one bromine. So 1, 2, 3, 4, 5. Okay, so now I'm going to have my bromine at 4, at 3 and 4. Okay, I have bromine at 3 and 4, 3.4 dibromo dash 2.2 dimethyl dimethyl pentane. Okay, so now total number of positions, 3 plus 4 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So if here I would say I count from 1, 2, 3, 4, 5. Okay, so I would have bromine at 2 and 3, so I would have 2 plus 3, which is 5, and then 5 plus 4 plus 4. So 5 plus 8, it will be 13. Okay, so it will be 13 for the purple. The total of the purple will be 13, and then the total for the red would be 11. So the preferred one is the red. Is the red. Okay guys, that's all there is to it. Apologies to the disruption on my screen. I will disable that ASAP. Okay, thank you guys.